Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Today we're going to discuss about translational kinetic energy of a molecule. So let's start with motion of gas molecule. There are three types of motion of gas molecule, which is translational motion, rotational motion and vibrational motion. But we only consider two motion, which is translation motion and rotational motion in our syllabus. So translational motion is a motion in a straight line x, y and z, but rotational motion is a motion that rotates in x-axis, y-axis and z-axis. In this case, the moment of inertia for rotational motion is negligible because there are no intermolecular forces between molecules. So next, kinetic energy of any object is K equals to 1 over 2 mv squared. But for translational kinetic energy of a molecule, K equals to 1 over 2 m mean square speed. So we all know that mean square speed is also equals to 3 kT over m. So we can substitute this equation into this. We get an equation that K equals to 1 over 2 m times 3 kT over m. So we can cut these two m's and we can get an equation that K equals to 3 over 2 kT. So average translational kinetic energy of a molecule equals to 3 over 2 K. Small k refers to Boltzmann constant and T refers to absolute temperature. Is equals to 3 over 2. This also we can substitute as R over Na. Na refers to Avogadro constant and times with absolute temperature. We should not forget to convert degree Celsius into Kelvin because it's absolute temperature. So next, for n molecules of an ideal gas, total translational kinetic energy is equals to 3 over 2 mkT. For n moles of the ideal gas, the total translational kinetic energy is equals to 3 over 2 nRT. So the small n refers to moles and with 3 over 2, this capital N refers to molecules. So next, we're going to discuss about degree of freedom. To understand further, we can watch this video. So let's go.
The number of directions in which a particle can move freely is defined as its degree of freedom, or the number of independent coordinates required to specify completely the position and orientation of a particle in space is defined as its degree of freedom. Degrees of freedom are of three types. They are 1. Degrees of freedom of translational motion, Ft. 2. Degrees of freedom of rotational motion, Fr. 3. Degrees of freedom of vibration motion, Fv. Degrees of freedom of translational motion, Ft. These are due to translational motion of molecules. Maximum number of translational degrees of freedom is 3, irrespective of that the molecule may be monatomic or polyatomic, linear or non-linear. These are present at ordinary temperature. Degrees of freedom of rotational motion, Fr. These are due to rotational motion of a molecule about an axis passing through the center of mass of the molecule. Their number depends upon the structure of molecule. These are also present at ordinary temperatures. Degrees of freedom of vibrational motion, Fv. These are due to the vibrational motion of molecule about its equilibrium position. The number depends upon the structure of the molecules. These are produced only at high temperatures. Degrees of freedom 4. Monatomic gas. A monatomic gas molecule can move linearly in any direction along three coordinate axes. Hence, its degrees of freedom is Ft is equal to 3. Examples: molecules of noble gases like helium, neon, argon, etc. Diatomic gas. The center of mass of two atoms is free to move along three coordinate axes. Hence, its translational degrees of freedom is Ft is equal to 3. The molecules, if these gases can rotate about a perpendicular axis passing through their center of mass in two directions. Hence, its degree of freedom of rotating motion is Fr is equal to 2. Therefore, total degree of freedom F is equal to Ft plus Fr is equal to 3 plus 2 is equal to 5. A triatomic or polyatomic gas, nonlinear. Degrees of freedom of translational motion Ft is equal to 3 and degrees of freedom of rotational motion Fr is equal to 3. Therefore, total degree of freedom F is equal to Ft plus Fr is equal to 3 plus 3 is equal to 6.
So, degrees of freedom for monoatomic gas F equals to 3 because 3 directional of translation motion along X, Y and Z axis only. So, there's no rotational motion. So, example of monoatomic gas is helium, neon and argon and etc. So, for diatomic gas F equals to 5, which includes 3 translational motion and 2 rotational motion. Example diatomic gas is hydrogen, oxygen, nitrogen and etc. For polyatomic gas, degrees of freedom, total degrees of freedom is F equals to 6, which includes 3 translational motion and 3 rotational motion. Example, polyatomic gas, H3O, H2F, carbon dioxide and also water. So this table shows degrees of freedom. So for monoatomic gas helium, we have 3 translation motion and 0 rotational motion. So total degrees of freedom F equals to 3. For diatomic gas oxygen, we have 3 translational motion and 2 rotational motion. So the total degrees of freedom equals to 5. For polyatomic gas, we have 3 translational motion and 3 rotational motion. So the total degrees of freedom is equals to 6. For average kinetic energy per molecule, we have the formula is 3 over 2 kT. For diatomic gas equals to 5 over 2 kT, and for polyatomic gas we get 6 over 2 kT. We can simplify and we can get 3 kT. So let's move on to a question. The question states that a tank has a volume of 0.700 meter cube and contains 2.50 mole of helium gas at 10 degrees Celsius. If helium behaves like ideal gas, calculate the total translational kinetic energy of the molecule of the gas and the average molecular kinetic energy. So first of all, what do we have in the question? We have volume, we have number of mole, and the question also stated helium gas, which is a monoatomic gas, that means 3 degrees of freedom, and we have the temperature 10 degrees Celsius. So the question they asking for only translational path energy. So F equals to 3 of the molecule of the gas. So it's not just a molecule but the whole gas. They're asking for the whole gas. So B, we have 0.7 meter cube and N equals to 2.5 mole. And helium gas is a monoatomic gas. So helium is a monoatomic gas which have degrees of freedom F equals to 3. And temperature given is 10 degrees Celsius. So temperature 10 degrees Celsius we have to change to K, which is an absolute temperature, Kelvin. So 10 degrees Celsius added up with 273, we get 283 Kelvin. So first of all, for 1 degree freedom, the equation is 1 over 2 kT. Since helium has 3 degrees of freedom, so we multiply 1 over 2 times 3 times with n. So we get 3 over 2 n kT. But do we have total molecules which is capital N from the question? No. So we don't have total molecules, so we use number of mole which refers to small n. So nkt is also equals to nRT because both are the same because we are using PV equation. So PV equals to nRT or nkt. So 3 over 2 nkt, we substitute 3 over 2 multiply with 2.5 and 8.31 times with 283. We get answer 8.82 times 10 to the power of 3 joule. And it also can written as 8.82 kilojoule. So next is for average molecular kinetic energy. So average and mean molecular kinetic energy are same. So for average means the question asking for one molecule. So for the equation for average kinetic energy is 1 over 2 nkt. So since monoatomic gas, helium has degrees of freedom F equals to 3, so we multiply with 3. We get 3 over 2 kT. So 3 over 2 we substitute with 1.38 times 10 to the power of negative 23 times with 283 the absolute temperature. We get the answer 5.86 times to the 10 to the power of negative 21 joule. So
Assalamualaikum and hi, my name is Nur Shazwani binti Mahmud from S15P12. So in this video, I'm going to explain to you guys principle of equipartition of energy. So equipartition of energy states that law of statistical mechanics stating that in a system in thermal equilibrium, on the average an equal amount of energy will be associated with each independent energy state. Sorry, but what? Carrot tak faham lah. I don't really understand. Skop pun tak faham. Dah lah kena gigit ni. Nampak tu? Explain more detail please. Kiranya macam ni lah. Energy ni dia share equally between different degree of freedom. Therefore, each degree of freedom of any molecule has an average and equal to half kT, where K2 stands for Boltzmann constant and T for absolute temperature. So here's an example of question untuk lebih memahami. A monoatomic and diatomic gas with equal molecule are both supplied with 200 joule. What will be the energy along each dimension? As we already know that degree of freedom of monoatomic gas adalah 3, while for diatomic gas adalah 5. 5 kerana dia punya translation kinetic is 3, while rotational kinetic energy dia is 2. Therefore, total adalah 5. We know that energy is equally distributed along all the dimension. So, we can simply bahagi 200 bahagi dengan 3 untuk monoatomic and 200 bahagi dengan 5 untuk diatomic. So, we can get the energy for each dimension. Guys, I think that's the end of my explanation for this topic. Thank you so much for watching and listening. And good luck to all of us. Ching!
Good morning, madam and my friends. I'm Angweiting from S15P6. Today, I'm going to make a conclusion about the subtopic 13.3, the internal energy of gas. So, what is the internal energy of gas? The internal energy of gas, U, is defined as the sum of the total kinetic energy and the total potential energy of the gas molecule. But in ideal gas, the intermolecular forces are assumed to be negligible, thus the potential energy of the molecule can be neglected. So we can see here So we can see here as the definition mentioned that U is defined as the sum of the kinetic energy and the total potential energy. And the potential energy can be neglected because the intermolecular forces are assumed to be negligible. So our potential energy is 0. So we can get an equation U equal to KE, kinetic energy. It's a total kinetic energy of gas. Okay. So in this subtopic, we have two formula. U equal to F over 2 NKT, and then another one is U equals to F over 2 nRT, where the N here is the total number of molecule. Total number of molecule where N here is the number of mole. Okay. And then K and R here is a constant, is 8.31, and then the T here is temperature. And as a gentle reminder that our temperature need to change to Kelvin. So now let us proceed to question number 1. What is the internal energy of 4 moles of the diatomic gas at 137 degrees Celsius? So first we need to take out the information that the question gave. Internal energy, they want us to find U. U. And then 4 moles is N equals to 4. And then diatomic gas give us the degree of freedom F equal to 5. And then we need to change the 137 degrees Celsius to Kelvin, which plus 273. Okay, so we get equal to 410 Kelvin. Okay, now we can apply our formula. U equal to F over 2 nRT. Why we use this formula instead of U equals to F over 2 NKT? Because the question gives us the number of moles instead of the total number of molecule. Okay, so we just substitute our value here. F equal to F equal to 5 over 2. 5. And then over 2, N is 4, R is 8.31, and then T is 410. So at the end we will get 34071 joules. Okay.
Hori henga henga heng, hori ong ong ong, hori onga onga ong, hori what, hori wala, hori heng ong wala.
Okay, here now is question 2. Carbon dioxide is polyatomic gas, means that carbon dioxide CO2 more than 2 atoms, and then determine the internal energy of 10 kg of carbon dioxide gas at temperature of 293 Kelvin. Given that the molar mass of carbon dioxide gas is 44. First, we need to take out the information that given. Okay, we know that pen. Okay. I know that U is equal to F over 2 and RT. So we have an information polyatomic gas means that the degree of freedom F is equal to 6 because it's polyatomic gas. And then 10 kg of carbon dioxide gas means the mass is 10 kg at temperature of 293 Kelvin. Temperature is 293 Kelvin. We don't need to do anything at the temperature because the question already give in Kelvin. Okay, if the question give us in degrees Celsius, so we must change before substitute in the equation. Okay, given that the molar mass is bigger and is equal to 44. Okay, so we have this all information, so eventually you can sub in the equation. nRT F equal to 6 over 2 and is equal to M molar mass over number of moles is equal to mass over molar mass RT. So we can substitute sorry. Okay. So we can substitute here. U equal to F over 2 and R 6 over 2 M 10 over 44. R is 8.31. T is equal to 293 Kelvin. So if we calculate, we can get 1.66 exponent 3 joules. Okay, now we proceed to question 2. Carbon dioxide is polyatomic gas, means that carbon dioxide is more than 2 atoms. Okay, determine the internal energy of 10 kg of carbon dioxide gas at temperature 293 Kelvin, given that the molar mass of carbon dioxide gas is 44. Okay, first, what we need to do is to take out the information that the question gave. Okay, carbon dioxide gas is polyatomic gas. What information give us in this sentence? Okay, so polyatomic gas give us the degree of freedom is equals to 6, and then 10 kg means that the mass is 10 kg. Okay, and then at temperature of 293 Kelvin, so temperature is 293 Kelvin. The question already give us in Kelvin, so we don't need to change anything. If the question give us degrees Celsius, so we must change to Kelvin before substitute into the equation. Okay, given that the molar mass of carbon dioxide gas is 44, means the big capital M is 44. Okay, now we can substitute our equation. U is equal to F over 2 and RT. Okay, so F over 2, and we must change to mass over molar mass because the question give us the mass and molar mass. Okay, RT. Then F is equal to 6 over 2, M is equal to 10, molar mass is equal to 44, R is equal to 8.31, T is equal to 293 Kelvin. So eventually we can get U equal to 1.66 exponent 3 joules. Okay, now we go to number 3. A. Calculate the internal energy of 4 moles of polyatomic gas at 285 Kelvin. So I am pretty sure that you all already mastered this question because I have explained a lot in the previous question. Okay, so what we know, as usual, we must take out the information that we got. Okay, so 4 moles means number of moles is 4. Okay, polyatomic gas means F equal to 6 polyatomic gas. Okay, temperature is 285 Kelvin. Okay, then we substitute the equation F over 2 and RT. Okay, F is equal to 6 over 2 and is equal to 4. R 8.31 and then temperature 285. Eventually we can get 2.84 times 10 to the power of 4 joules. Okay, A is very easy, right? Now we proceed to question 3b. Calculate the change in internal energy for 3 moles of hydrogen gas if it is heated from 273 Kelvin to 323 Kelvin. Okay, this question is slightly different that we do before. Okay, first we need to know that what is the question want us to find. Change in internal energy means the question want us to find delta U. So what is delta U? Okay, the question gives us number of moles N is equal to 3. Okay, so hydrogen gas is H2. It's a molecule, so this one is diatomic gas lah. Okay, diatomic gas means the F degree of freedom is equals to 5. Okay, then our initial temperature, because they want us to find the change in internal energy, so there is a change in temperature. So initial temperature is 273 Kelvin. Final temperature is 323 Kelvin. Okay, now we can make full use of our equation. Delta U is equal to our U final minus our U initial. Okay, so delta U is equal to F over 2 and RT final minus F over 2 and RT initial. Okay, so we can get the equation. We can factorize out F over 2 and R, and then T final minus T initial. Okay, so we can just substitute our value in the equation. Sorry. Equal to F is 5 over 2, N is 3, R is 8.31, then final temperature is 323, initial is 273. Okay, so we can get an answer of 3.116 exponent 3 joules. Another way around, can write in 3.116 kilojoules. Okay, that's all from me. Thank you. Thank you and good luck in SPSBM.